formation by a convex mirror. Let us consider the figure. Object AB is placed in front of the mirror MN. Incident rays AQ is starting from point A and traveling parallel to the principal axis. AR going towards the center of curvature as shown in the figure. How this get reflected and form image A1, B1 can be understood from the figure. It is clear that the image is smaller than the object. Behind the mirror, image is formed. The nature of the image is erect. As the reflected ray do not actually cross one another, the image is a virtual image. The nature of the image formed by a convex mirror does not depend on the distance of the object from the mirror. These images are always virtual, smaller than the object and situated behind the mirror. Let us look at the types of image formed by a convex mirror. When an object is placed at infinity, the image is formed at the focus. The size of the image is much smaller than compared to that of the object as shown in the figure. In this figure, P is the pole of the mirror, F is the principal focus, and C is nothing but the center of curvature. In this diagram, the incident rays are parallel to principal axis and emerge on the convex mirror. The reflected rays are meet at a focus. This is nothing but the laws of reflection. Second thing is that when an object is placed at finite distance from the convex mirror, a virtual image is formed between the pole and focus of the convex mirror. The size of the image is smaller than the object as shown in the figure. In this diagram, TS is the object, T1 is the image of T and S1 is the image of S. F is nothing but the principal focus and C center of curvature. Let's begin the concept of divergence and convergence. For this, we are going to proceed for a small activity. Take 5 sticks from matchbox, arrange them so that their heads come together at a point. In this arrangement, head of the matchsticks are said to have converged. Now arrange the sticks so that their uncoated ends are together at a point. The heads are separated apart. In this arrangement, the heads are diverging from the point. A concave mirror is also called a focusing mirror. This is because, as shown in the figure, parallel rays get focused after reflection in this mirror. size of the image produced by these mirrors can be larger or smaller than the object, depending upon the distance of the object from the mirror. A concave mirror is also called a dispersing mirror. This is because, as shown in the figure, parallel incident rays get dispersed after reflection in this mirror. The size of the image produced by the mirror is always smaller than the size of the objects. How will you find out if a mirror is concave or convex? The special mirror which is used for shading is a concave mirror. When held close to the face, it gives virtual and larger image of the face. If this same mirror is taken further away from the face, the image gets smaller and smaller. The mirror used in the cars and motorcycles are convex mirrors. In these mirrors, the image of our face is erect and smaller, and it remains erect but becomes smaller and smaller when the mirror is taken away from the face. As a result, we can see the images of the surrounding also in the mirror. We can determine the nature of the mirror by studying the images produced by them. The image produced by a plane mirror is a virtual image. This image is produced at a point from which the reflected rays appear to diverge, as shown in the figure. This image cannot be obtained on a screen as the rays do not actually meet there. When light rays collected at a point after reflection from a spherical mirror, they can say that they are said to converge. When you want to bring light together at a point, a converging light beam is used. Doctors use such a beam to converge light on a tooth, ear, nose, etc. Equipments using solar energy can also converging light. When light rays starting from a point spread out after reflection by a spherical mirror, light is said to have diverged. When we want light rays to spread out from a source, a diverging beam is used. As for example, in street lamps. Uses of concave mirror. Most of the concave mirror are used in shading because of their reflective and curved surface. During shading, the concave mirror forms an enlarged and erect image. When the mirror is held close to the face. Concave mirrors are also used in ophthalmoscope. Concave mirrors are used in optical instruments such as ophthalmoscope. Ophthalmoscope consists of a concave mirror with a hole in the center. The doctor focuses through the small hole from behind the concave mirror while a light beam is directed into the pupil of the patient's eyes. This makes the retina visible and makes it for doctor to check. Concave mirrors are also used in astronomical telescopes. Concave mirrors are used in astronomical telescope. A concave mirror of a diameter of 5 meters or more is used in the objective. Concave mirrors are also used in headlights. Concave mirrors are widely used in headlights of automobiles, motor vehicles, torchlights, railway engines, and so on as reflectors. These concave mirrors are used in these instruments as reflectors. The light source is placed at the focus of the mirror. After reflecting, the light rays travel over a huge distance as parallel light beam of the intensity. Concave mirrors are also used in solar furnaces. Large concave mirrors are used to focus sunlight to produce heat in the solar devices. They are also used in solar ovens to collect a large amount of light energy in the focus of the concave mirrors for heating, cooking, melting metals, and so on. This is all about the uses of concave mirrors. Let's begin the uses of convex mirror. So many students, what are the uses of convex mirror? For a long time, we are learning the uses of concave and convex mirror. I hope so. It's very clear now. Convex mirrors are used inside buildings, large offices, stores, hospitals. Use a convex mirror to let people see around the corner so that they can avoid running into each other and prevent any collision. Convex mirrors are also used in vehicles. It's widely used as rear view mirror in automobiles and vehicles because it can diverge light beam and make virtual images. Convex mirrors are also used for security purposes in various places. They are places near ATMs so that bank customers can check if someone is behind them. This is all about the uses of convex mirrors. Let's begin the new topic, that is sign conventions. According to the sign convention, the pole of the mirror is taken as the origin. The principal axis is taken as the x-axis. The sign conventions are as follows. Number 1. The objective is always kept on the left of the mirror. All the distances parallel to the principal axis are measured from the pole of the mirror. Second, all distances measured towards the right of the pole are taken to be positive. Distances measured towards the left of the pole are taken to be negative. This is the second sign convention. Third point, distances measured vertically upwards from the principal axis are taken to be positive. Fourth point or fourth sign convention, distances measured vertically downwards from the principal axis are taken to be negative. And last point, the focal length of a concave mirror is negative, while that of the convex mirror is positive. This is all about the sign convention.